Okay, students, today's topic is transformer on no load. This topic will help you in building the concept of transformer. So, as you see that the heading is transformer on no load, means there will be no load at the secondary side. We will apply an alternating voltage at the primary side, let it be V1. Now the alternating voltage applied to the primary winding will cause flow of alternating current in the primary winding. Since the primary coil is purely inductive and there is no output, so the primary draws the magnetizing current only. Means in the primary winding only Im will be drawn. The function of this current is merely to magnetize the core. Now, as the transformer is truly ideal, the magnitude of Im should be 0 by virtue of assumption made in the notes that I have uploaded earlier. Since the reluctance of the magnetic circuit is never 0, so Im has definite magnitude. The magnetizing current Im is small in magnitude and lags behind the supply voltage by an 90 degree. Now this magnetizing current produces flux in the core. As I have earlier told you that the role of Im is merely to magnetize the iron core of the transformer. And as the circuit is purely inductive, so Im will lag behind V1 by an angle 90 degrees. And this magnetizing current will produce an alternating flux in the core, which is in time proportional to the magnetizing current. Now, as the supply is alternating, so the flux will also be alternating in nature, and its instantaneous value will be phi max sine omega t. Now, the varying flux is linked with both the windings, so induced EMF in the primary and secondary winding is given by E1 equals to minus N1 d phi by dt, where phi is phi max sine omega t. So it will come as minus n1 omega phi m cos omega t, or it can be written as minus n1 omega phi max sine omega t minus pi by 2. Similarly, E2 will be written as N2 omega phi max sine omega t minus pi by 2. So as you can see that E1 and E2 are lagging behind the flux by an angle 90 degree, and E1 into E2 are both in same phase. Since the primary winding has no ohmic resistance, so the applied voltage to primary winding is to only oppose the induced EMF in the primary winding. Hence, the applied voltage to the primary will be given by V1 equals to minus E1, which is equals to minus N1 omega phi m sine omega t minus pi by 2. So there are 3 points regarding this topic. First one, that induced EMF in primary and secondary winding, that is E1 and E2, lags behind the main flux by pi by 2. And E1 and E2 are in phase with each other. Second point is, the applied voltage to the primary voltage or primary winding leads the main flux by pi by 2 and is in phase opposition to the induced EMF in the primary winding. And third point is that the secondary winding voltage is V2, which is equals to E2, and there is no voltage drop in the secondary. So combining these 3 points, that is, first, E1 and E2 are in same phase. E1 and E2 are in same phase and they are lagging behind the flux by an angle pi by 2, and it is proportional to magnetizing current. Second point is that V1, that is applied voltage to the primary winding, leads the main flux by an angle pi by 2. V1 is leading flux by an angle pi by 2 and is in phase opposition to E1. It is V1 equals to minus E1. And third point is that the secondary voltage V2 equals to E2 and there is no voltage drop in the secondary, that is E2 equals to V2.